In this video, we will understand the concept of displacement time graph. First of all, we will use the symbol S for displacement. Distance measured with respect to a point is the displacement, and the unit of displacement is meters. T is the symbol that is used for time taken, and the units are seconds. Now, in a displacement time graph, the displacement goes on the vertical axis, the y-axis, and the time goes on the horizontal axis. We can use displacement time graph to represent the motion of an object. So now let's go to the x-axis and the y-axis. The horizontal axis is labeled with the symbol T, T for time, and this is seconds. The vertical axis is for S, that is the displacement, and the units are meter. And let's say we are drawing a line like this. Now, first of all, we have to define what is velocity. Velocity is defined as rate of change of displacement with respect to time. That means displacement is on the vertical axis, time is on the horizontal axis. Therefore, the gradient of this displacement time graph represents velocity. This is the change in displacement. This is the change in time. Therefore, the rate of change of displacement with respect to time is velocity. And we also know that this is the definition of slope of a line. That is equal to rise over run. We can also use the gradient formula y2 minus y1 over x2 minus x1 if it's a straight line segment. Now, let's look at some different examples of displacement time graph. So displacement goes on the vertical axis, time goes on the horizontal axis, unit of time is second, unit of displacement is meter. Now let me draw a line which is parallel to the x-axis. What do we observe? We observe that there is no change in displacement. The displacement is neither increasing nor decreasing because the value throughout is exactly the same. The y coordinate is exactly the same. The displacement remains the same. It means that the particle is at rest. The particle is stationary. Let's draw a similar graph. Something like this, in which a line is starting from the origin and it has a positive slope. Again, time goes on the horizontal axis, displacement goes on the vertical axis, and this time, since this is a straight line has a constant gradient, constant slope. What is the slope of a displacement time graph? That is velocity. Therefore, this line represents constant velocity.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
Let me draw another graph. This time, the graph is a curve. So let me draw a line and the graph is going up like this. Now, let me label the y-axis with displacement. Let me label the x-axis with time. The units are mentioned over here. What we observe over here is that the gradient is changing because it's a curve. And the gradient is getting bigger and bigger. How do I know this? I can draw some line segments, for example, at this point, and then at this point, and then at this point. we can see that the gradient of the line segment is increasing. That means we can write the slope is not constant, the slope is increasing. What is the slope of a displacement time graph? That is velocity. In other words, velocity is on the rise. Velocity is increasing. In other words, the acceleration is constant. So that is what is represented by this displacement time graph. Now let's come to the last point. That is the formula for average velocity, that is displacement from a point divided by time taken, because displacement is associated with velocity. Displacement is a vector quantity, velocity is a vector quantity. But if the examiner asks for average speed, we will write the distance covered divided by the time taken. Now, when we talk about distance, we talk about total distance. When we talk about displacement, this is with respect to a point. Whatever point is the starting point, with respect to that particular point, we will find the displacement and it will be divided by time taken. So what have we studied in this particular video? We have understood the basic idea of a displacement time graph. Displacement goes on the vertical axis, time goes on the horizontal axis. We have seen different line segments and what does each line segment means. That's what the video is all about.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels Maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.